All right, guys, you know the drill. We have an Ozster quiz coming up in, 2 days now, and I have to make a video for it. So let's get started with the video. So let me start presenting a window. This is for control systems design quiz number, I think we're on quiz number 3 right now. All right, so so we have that being shared, and we're gonna take a picture of what is on practice quiz number 3. Yeah, this is practice quiz number 3. Okay, so we have this problem over here. Actually, one thing that I forgot to do was I forgot to expand this out just so that I have enough room to do stuff. Okay, let that load. And I am presenting, right? Yes, I am presenting. Okay, that's good. Okay, so we're on problem number 1, and I'm gonna put that right over here. I'm not selected on the page. Okay, it can just paste. Oh, it's loading. Okay. Okay, so this is problem number 1, practice quiz number 3. Okay, so during class, I actually got a lot of this stuff wrong. Not gonna lie, I think I got every single question wrong, and that's not good. That's not a very good start. But I do know why I got it wrong. I talked with him afterwards, and I was just like, "Oh, I got this wrong." Okay. So basically, what that tells me is you can get a lot of stuff wrong by accident for just like very, very simple mistakes. So really, it's best to just like look over your work and take your time with this quiz. Honestly, just spend as much time as you can just looking over your work and making sure you didn't make any mistakes at the end. And I'll tell you where I went wrong, so you guys cannot make this mistake. But anyway, let's continue with this. We are on problem number 1, and the problem is for the system with the following characteristic equation, determine number of sign changes, number of RHP, IA, and LHP roots, the stability of the system. Find the roots of the auxiliary polynomial PA of S if there is any row of zeros. And then he gives you the P of S equation, and the lines to put the number of sign changes and so on and so forth. Okay. So to start this problem off, we're always going to make the first 2 S's. So we're going to go like S5 and S4. All right. And the reason why is because the reason why I'm only doing the first 2 is because when you get to like S3, if you put down S3, S2, S1, S0, you might have to erase your rows because you could get a row of zeros. And if that happens, it's just a waste of time. So just put S5 and S4 or the first two S's that you see. So as you can see over here, so this is everything. This is all the odd numbers. And you always start, if it starts with an odd exponent over here, then you start with the odd numbers. If it starts with an even exponent, then you start with the even numbers. So it's going to be 2, 6, and -8. And then we're going to start with the even numbers. So we'll just highlight those over here. It's going to be 1, 3, and -4. So if you just look at this question, what do you see over here? What do you see that like catches your eye? And I'll give you a couple of seconds to think about it. All right, so you might have noticed that if you look at this line and compare it to this line, if you just multiply 2, wait, am I doing something? Sorry, if you multiply 1/2, so if you do this row times 1/2, then you get this row. What does that tell you? The next row is going to be a row of zeros. If you can multiply the whole row to get to the next row, you will get a row of zeros. And that means that you don't have to do the equation. And you can just say S3, and then B1 is equal to 0, and B2 is equal to 0, right? But if you want, I could show you, I could prove to you that it is going to be zeros. So if you do B1, the equation would be 1 times 3 minus, sorry, not 3. It's going to be 1 times 6 minus 3 times 2 minus 3 times 2 over 1, and that's is equal to 0. For B2, it's going to be 1 times negative 8. That doesn't look like an 8. So 0. Minus 2 times negative 4 over 1, and that's also equal to 0. So that right there is proof enough that it's always going to be a row of zeros. That's one thing that you can always check on the quiz. And we're going to box this off, and we're just going to put some dashes through there. And that's why I was saying if you do all the S's over here, if you list all the S's, and you get a row of zeros, then you're going to have to erase that so that you could put S3 down here. So, just start with the first two S's. Now, how do we find the row S3? Well, we're going to find PA of S. PA of S. What is PA of S? Well, it's whatever the last row was. So it's going to be, we're going to focus on this row over here, right? And we're just going to put the coefficients with the S's. So if a better way to explain this is we're focusing on all of these numbers with the little dash on the top, because that's the last row. So we're going to do S4 plus 6s cubed minus 4 is equal, no, that's fine. S4, s to the fourth plus 6s cubed minus 4. All right, after you do that, you take the derivative. Okay, so let's take the derivative PA prime of S. You can write the derivative how you want. But this is 4s cubed plus 18s squared. And if you take the derivative of negative 4, it is 0. So this is our equation. Let me just make sure that this is right. Yep. Wait, hold on a second. Oh, I wrote something wrong here. I meant to say this is actually supposed to be, I looked at the wrong number. This is 3s squared. Let me just erase all of this, actually. See, another simple thing that you can make a mistake on. Do not make these mistakes on the quiz. Take your time and just do it right. So this is 3s squared. So if you take the derivative of that, this is 6s. Okay. After you do that, we can fill these numbers into s cubed row. So this is the 4, and this is plus 6. Oh, sorry, not plus. 4 and 6. So B1 is equal to 4 and B2 is equal to 6. Now we can carry on with the other values. So we're going to find s squared now. I'm actually going to rewrite this row just so it looks a little bit better. 1, 3, and negative 4. 1, 3, and negative 4. And now you can guys see the row a little bit better when I try to find these numbers. So C1 is equal to, it's going to be, C1 is equal to 4 times 3 minus 6 times 1 over 4. That is going to give us a value of 1.5. 4 times 3 minus 6 times 1. 12 minus 6. 4, 8, 12. Yeah, 12 minus 6 is 6 divided by 4. Yeah, I think it's going to be 1.5. Okay, and that is where I messed up. I think I used the wrong numbers. So this is going to be 1.5. That's one reason why I messed up on this question. C2 is equal to there is no. Oh no, there is a C2. C2. Okay, so here's one thing. So if you see over here, he's been like talking about this in class. But I'm going to show you right now. So if you do the equation 4 times -4, right? That is our equation so far. It's going to be, because since there is an imaginary like just 0 over here, just pretend that there's a 0 over here. You do 4 times -4, and then you're going to do 0 times 1, right? 0 times 1, and that's going to give you a value of 0. And this is going to be over 4. This is equal to 4 times -4 divided by 4. And you could just cancel these terms out, which gives you -4. So in class, when he always like boxes off this value, and just kind of like puts it over here, -4, and then he boxes off this value, it's to kind of show you that it's going to be that value no matter what. And the reason is because there is a 0 over here, and it'll just always be a copy. The only time it's not is when you're working with epsilon, and I think it shows up in the next question. When you're working with epsilon, then there's a chance that it won't be able to be just copied over, and you could just like skip this equation over here and just cross it out and be like, okay, well, that's -4. Anyway, now we're going to go on to S1. So we're going to find D1. D1 is equal to, it's going to be 1.5. D1 is equal to 1.5 times 6 minus, this is going to be -4 times 4. I believe I did that right. It's going to be divided by 1.5. I don't want to recalculate this. Oh, I definitely did something wrong here, though. Okay, so I guess I will have to bring out my calculator. See, I'm still doing some stuff wrong, even though I'm looking back at it, and I thought I got the question right. Still doing a couple of things wrong. So as I said, this is one of those quizzes where you definitely want to look over your work. It's going to be 1.5 times 6. That's basically going to be plus 16. And it's going to be divided by 1.5. Okay, that's going to be 16 and 6 repeating. Let's go math. Rack. 50 over 3. So this is going to be 50 over 3. 50 over 3. Now we're going to find S0. What did I say before? If you have a 0 over here, right? That just means that it's going to be a copy of the one above. So this is going to be -4. There you go. And then you could box that off. Okay, so we found all of these values, which is good. And that will be able to tell us the sign changes. When you look at the sign changes, you're looking at only the first number in each row. So basically, just all of, you just go down, you're going with all of these numbers over here. Just all of these numbers. Look at what their signs are. So 2, positive, 1, positive, S3, positive, or sorry, 4 is positive, S2, 1.5 is positive. 50 over 3, positive. This one is negative. So there is one sign change. One sign change. So that tells us there is at least one RHP root. But we have to go on with this problem to find out how many there actually are. And I will tell you right now, it is not just one. So now what do we do? So we're going to go back to this top part over here. And we're going to look at this PA of S. Right? We're just going to recopy this, honestly. So just copy this. Okay. So we have this over here. PA of S is equal to this. Let me delete this part. Okay. PA of S is equal to this. We're going to set this equal to 0. And to do that very quickly, let me just delete this. Okay, so we're going to set that equal to 0. Okay. Now we're going to find the roots of this. In class, he said that we are able to use the calculators. Yeah, we can use the calculators to solve this problem. Problem is, I don't know how to do that. Actually, this is like the one time where I'm actually not going to advise you to use the calculator and to solve the problem like he does in class. So if you were hoping to find the roots using the calculator, well, you're just going to have to look up a YouTube video on how to do that because I couldn't find one myself. I believe, though, there should be some YouTube videos that do solve this type of equation, right, and gives you the roots. But you might need to actually download something onto your calculator. And I don't want to do that. I know how to do this problem without the calculator, so I'm going to teach you without the calculator. To do this problem, he says to put s squared is equal to x. So anytime you see s squared, it's going to be equal to x. Now, if you have s to the fourth, that's basically equal to s squared to the second, right? So over here, it's going to be x squared. This is going to be plus 3. And since you see s squared over here, it's going to be x minus 4 is equal to 0. This is where I messed up again. I did x plus 3, x plus 1. And that's wrong. I just did a very simple mistake in trying to factor this out. So this is actually supposed to be x plus 4 and x minus 1. So if you don't, whoops, this is supposed to be x minus 1. If you don't want to mess this up on the quiz, and this is very important because this is basically how you're going to get most of your answers for this problem, you can actually just multiply this through just to check. So if you do x times x, that's x squared, x times negative 1, so it's going to be negative x, 4 times x, so it's going to be plus 4x, minus 4 is equal to 0. And if you combine these two, that gives you positive 3x. And you can tell from that that this answer is correct. So that is just a way to check on how to do this problem right. But anyway, let's go on to the next part. So right over here, you're supposed to find the values of x, right? Yes. Yes. So we're going to split these two up. So this is x plus 4 is equal to 0. And x minus 1 is equal to 0. Okay. So we have that. And we have x is equal to negative 4. And x is equal to 1. Very simple, right? This isn't too complicated. We just have one more step after this. So we said that, so we have both of the x's, x is equal to negative 4 and x is equal to 1. But now we also have s squared is equal to x. So this is equal to s squared, and this is also equal to s squared. So what do we do with that? We just say s squared is equal to -4, s squared is equal to 1. Okay, and now we just solve out for it. Take the square root on both sides. And then you get s is equal to plus or minus j2. And this is s is equal to plus or minus 1. Very simple. With that, now you can fill in the rest of the rows. So just to give you guys an idea, let's actually plot these numbers. So we have +1, we have -1, we have plus j2, and we have minus j2. Okay, so you can see right here we have one RHP, we have one LHP, and we have let me just go like this and like this. We have two IAs. So let's fill that in. We have one RHP, and we also have one sign change. So that means there's going to be two RHPs. Two RHPs. One RHP from the graph and one RHP from the sign changes. The IA is going to be 2. The LHP is going to be 1. And the stability of the system. Actually, before I get to the stability of the system, you can see right over here that the exponent is 5. And if you take all of these three numbers and add them together, 2 plus 2 plus 1, that is equal to 5. So that tells you the, what is it? The first s value, the first exponent for the s, tells you how many are going to be like in here, right? So if you for some reason get that like this one is going to be like 1 or 0 or something like that, then you know that that's wrong, right? Because that would add up to 4 and not 5. Just as a reminder. Okay, actually I can keep that there. The stability of the system, it is going to be unstable because we have RHP roots. That is from the last quiz. So this is unstable. Just remember that stuff from previous lessons still apply to stuff from these lessons, and the unstable stable thing, that was pretty easy, so it's fine. And the roots of PA of S, I'm just going to write them over here. Actually, I don't even have to write them. These are the roots of PAS. So you could just copy these. Right over here, right? So that's where you put the roots of PAS. But I don't have enough room to do that, so it doesn't really matter too much. You could just put that up there. Now we're going to go on to the next problem. So problem 2. Okay, problem number 2. For this problem, we're gonna start with the same thing. It's the same process over and over again for every single one of these problems. You always have to do this at some point or another. You might not have to start it this way, but you're gonna have to do it. So we're going to do S4 and S3. Okay. And so we have this value, and this value. Okay, so we have 2, 6, and 3. Then we have these two values, so it's 1 and 3, right? Okay, so now we're going to find S2. So we're going to do, this is going to be B1. This is going to be B2. B1 is equal to 1 times 6 minus 2 times 3. Also, I just want to let you guys know. So if you multiplied, if you're thinking like, oh, okay, so 2 times a half is 1. 6 times a half is 3. It could be a row of zeros, but if you do 3 times 1/2, that does not equal 0, right? 3 times 1/2 does not equal 0. So this is not going to be a row of zeros. But as I said before, if you do 2 times a half and 6 times a half, it gives you the next two numbers. So you might be able to tell that 1 times 6 minus 2 times 3 is equal to 0. So B1 is going to be 0. B1 is going to be 0. And B2 is going to be, B2 is equal to 1 times 3. What did I say before about this type of problem? If you have a 0 underneath, then this is going to be 3. 1 times 3 times 0 times 2, or plus 0 times 2. Yeah, I'm not going to do this problem. Right? We know it's going to be 3, so just say it's 3. No need to do more work. Okay? So we have that. Now, this is where I went wrong. I continue the problem normally, and for C1, I get infinity. Of course I would get infinity, right? If you did the problem out, then you can tell that I would get infinity. But when I got infinity, that's where I put epsilon, and you do not want to do that. What you want to do is when you get 0, that's when you put epsilon in. So we're going to say 0 is equal to epsilon. Okay? So over here, we put in epsilon. And actually, I'm going to check my notes for that one because I really thought that it's when you see infinity and not when you see 0. But I could just be getting it wrong, you know. Let me just check my notes real quick. You can skip this part of the video as I check. Okay, so for my notes, if I go to some problem with epsilon. Replace 0 with positive constant e. Okay, there we go. So simple as that. I just didn't know what the hell I was doing. When you see a 0, replace it with... If you see a 0 and it's not a row of zeros, replace it with epsilon. Let's move on. S1. We're trying to find C1. C1, hold on. C1 is equal to epsilon times 3 minus 3 times 1 minus 3 times 1 over epsilon. So that's going to give you 3e, or 3 epsilon, minus 3 over epsilon. Okay? So let's write that over here. 3 epsilon minus 3 over epsilon. And then we're going to find the last one, S0. What's the rule, guys? So this is going to be D1. What's the rule over here? If you have a value times whatever, and the value underneath this one is 0, then you have the same value. So this is 3. Okay. So we have that. Okay. So now we could look for the sign changes. This is going to be epsilon. Epsilon we just treat as Epsilon we just say is 0. So actually I think I need to do one more thing. Yes, I need to do one more thing for this problem. Okay. So we have to take the limit of all of these. So we're going to take the limit. Let's start with the easy one. Limit when epsilon goes to 0 of the first one, b1, which is epsilon. That is equal to 0. Very simple. If you put 0 in for epsilon, it's 0. Okay. Now we're going to take the limit as epsilon goes to 0 of 3e, 3 epsilon, minus 3 over epsilon. Now, if you what am I saying? If you distribute the epsilon, it will be 3 epsilon over epsilon minus 3 over epsilon, right? That's just splitting up the fraction, right? And then you can get the limit, blah, 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 of epsilon goes to 0, of epsilon over epsilon is 1. So we're going to say 3 minus 3 divided by epsilon. That is equal to, since epsilon is going to 0, let's just say that epsilon over here is 0. That's going to be 3 over 0, which is infinity. So this is going to be 3 minus infinity, which is equal to negative infinity. All right. So basically, the value over here, we're going to say is negative infinity. So keep that in mind. Now we can do the sign changes. So for the sign changes are going to be 2 is positive, 1 is positive. Epsilon we say is 0, and 0 is neither positive nor negative, so there's no sign change. So we're just going to say that it's positive. Negative infinity is a negative, so it's negative. And then it goes back to positive 3, which is positive. So you can see right here that it goes from positive to negative, and then from negative to positive, also known as 2 sign changes. So this is 2. Since we're not going to find any roots, that immediately tells us that the RHP is 2. So there's going to, as I said before, if you have 2 sign changes, there's going to be at least 2 RHPs, but we're not finding any roots from this problem, so it's 2 RHPs. IA, we're not finding any roots, as I said, so there's going to be 0 IAs. The number of LHP roots, okay, to find the number of LHP roots, we have n. N is equal to 4, or the highest exponent is 4. And since we have 2 RHP roots and 2 IA roots, that means that, 0 IA roots, we do 4 minus 2 minus 0, which is equal to 2. So there's going to be 2 LHP roots. Just take the difference of however many roots you have from the previous problem. Stability of the system, this is going to be unstable again, sadly. And the roots is going to be, we don't have any roots, so it's going to be 0. Actually, that is not correct. It's not 0, because 0 can be a root. It's going to be not applicable, or no roots, or however you want to put it, but I just put NA. All right, so we did question number 2. All right, now I have problem 3. So yes, once again, do not make the same mistakes as I do for the quiz. You make the mistakes now, so you don't have to do it on the quiz. Control V. I'm not on the right page. Hold on. Control V. Good. Problem 3. The goal of vertical takeoff and landing VTOL aircraft is to achieve operation from relatively small airports and yet operate as a normal aircraft in level flight. An aircraft taking off in a form similar to a missile on end is inherently unstable. Control system using adjustable jets can control the vehicle, as shown in Figure A. Determine the range of gain for K, which the system is stable. Determine the gain K, for which the system is marginally stable, and the roots of the characteristic equation for this value of K. The roots, yep, the roots. Okay. So we're going to start with part 1. Part 1. Okay, so we're going to determine the range of gain K for which the system is stable. Okay, so we have this equation over here, right? And if you multiply everything through and you actually get the equation, it'll look like y of s over r of s. I'm not going to explain this because we've done this 10,000 times now for multiple quizzes. K s plus 2, s plus 10, and then if I expand this out, we could put the s in the front just to make it look nice, and s minus 1, and the top part is times 1, so that's fine. The bottom part is going to be 1 plus. It's plus because this part is negative, as we know. And it's going to be the same thing. K s plus 2 over s plus 10. Over here is the s, and s minus 1. So in the last quiz, I gave a little explanation that if you have, I'm going to do this in color too, if you have A over B divided by 1 plus A over B, that is equal to, gotta get these colors right. It's going to be equal to, what is that equal to? It's equal to A divided by, I'm just going to put the plus sign right now because I don't want to rewrite this. So, or I don't want to change colors again. Plus sign is going to be A over A plus B. Very simple, right? Okay, cool. Okay, s plus 2. Yep. So, with that being said, our new equation, and I guess I could write this in color too. Our new equation, y of s over r of s, is equal to k s plus 2. Oops. K s plus 2. Divided by, no. Oh my God. K s plus 2, and then it's going to be plus b. Let's do plus b. No, I forgot. Plus is going to be in black, and then b is going to be in purple. You know, I like doing this stuff, right? You know, I like doing this stuff, guys. If I didn't like doing it, then I wouldn't do it, right? But this, I hate. This one I do literally just for you guys, just like the color. Doing this in like a certain color for A, B, and just everything else in black. That I do just for you guys, just so that you can understand it a little bit better. I hate doing that. It takes so long, but anyway, it's going to be s plus 10, and s minus 1. Yeah, so yeah, as I said, I enjoy doing all of this. I enjoy making these videos and making sure that everybody is, doing well in the class. And I wish everybody to pass, but that takes a while, so I don't like that. Anyway, let's go on with the problem. This is going to be okay. So now we have to simplify this equation. I could do that in black, which is fine. To simplify this, you could distribute this top part out. You could not distribute it. It doesn't really matter. So we're just going to not ks plus 2. We're going to have to distribute it at the bottom anyway. Yeah, so we're going to do, you could do it like this, ks plus 2k. Or you could do it like one at a time first and then order it properly. But anyway, we have s. So we're gonna do these two first, and then we're gonna multiply it by s. So it's going to be s times s is s squared. This is s squared plus s minus 1. This is going to be plus 9s. Because s minus 1 and positive 10s make 9s. This is going to be negative 10. All right, so you have that. And then if you multiply these through, it just increases by 1. Increases all the exponents by 1. And then you can order everything properly now. So we have k s plus 2. As I said, if you have to take your time with this and do it like this, that's fine. It's better not to rush for this quiz because you could make a lot of mistakes. So the first one is going to be s cubed. The next one is going to be plus 9s squared. The third one is going to be minus 10s. And we have ks over here. So we're going to group these two together, plus ks. So let's do that like this. So this is our first group. And our second group is going to be, actually, it's not going to be a group because it's actually just plus 2k. 2k does not have a value of s, so it's going to be at the far right. And then one last thing we can do is we could do this. Okay, actually, what I could do is select this, bring it down. The last thing that we have to do is make this look a little bit nicer. So let me just select this and delete it. Put that 9s squared back to normal. Okay, so if you take out the s on both of these parts, you take it out like this, then you can say it's k minus 10, right? Same thing, just a better way to write it. So now we have the polynomial, which we will be using to find the s cubed, s squared list, right, that we've been doing this whole time. So as I said, we do have to do this every single time. It might not be the first thing that you do. The first thing that we had to do in this problem was find the polynomial, actually. But we did end up having to do this eventually. So we have s cubed. This row is going to be 1. Okay, so let me actually highlight these. So it's going to be this, and actually that's it, right? Yep. k minus 10. All right, and then the next row is going to be, if you can, go up this one, and this one, and this one. This is going to be 9 and 2k. We don't write the s's, but we are going to write the k's in. We have to write the k's in to find the k's, of course. Okay. We are now going to find S1. So this is going to be B1 is equal to, and we find B1 by doing 2k times 1 is 2k, and then you do minus 9 times k minus 10 over 9. That's going to be equal to, I'll just skip ahead, but you will have to solve this out for the quiz, obviously, to get the answer. 7k minus 90, right? Because it's just doing math, right? 9k, negative 9k, plus 2k, 7k, and then you do 9 times negative 10, which gives you negative 90. So that's our B1 value. 7k minus 90 divided by 7. No, divided by 9. Sorry, it's what, 11:42. I shouldn't be getting tired right now. Anyway, S0. We're going to find C1. What's the rule, guys? If the value underneath here is 0, I know it doesn't look like it's going to be 0 because we have this blocking it, but this should be right over here. If the value underneath is 0, then you're just going to copy. You're just going to copy it, right? Actually, what I can do, take this off, do this, and 2k. There you go. Happy. Okay. So we have that. Now we can find what this question is asking for. What is it asking for? Determine the range of gain k for which the system is stable. How do we find the range of k? The range of gain k for which the system is stable. Well, we just do this. We're gonna do everywhere we see k. Sorry, everywhere in the first column we see k. Hold on. Something like this because our columns look weird. Everywhere in our first column where we see k, we're going to set it equal. No, not set it equal to 0. We're gonna set it. We're gonna say greater than 0. So for the first one, 7k minus 90 over 9, we set that greater than 0. So if we multiply 9 by 0, that is 0. So it's going to be 7k minus 90. It's greater than 0. If we add 90, that is going to be 7k minus, 7k is greater than 90. Simply, we just say k is greater than 90 over 7. Very simple. This next one is even easier. 2k is greater than 0. What do we do? Well, we just divide by 2. That'll give us k is greater than 0. Very nice. So we can determine that the range of k is going to be 0 is less than k, which is less than 90 over 7. So k is less than 90 over 7, and k is greater than 0, or 0 is less than k, whichever. So this is the answer for problem number 1. Problem number 2 is a little bit of a I feel like we haven't practiced this too much, but it's not too hard. It's not like we can't do this problem. I feel like this one's a little bit new. I think he actually taught this at the beginning of class during the practice quiz, which I would not advise doing as a professor, because why would you teach some new material at the beginning of class during the practice quiz. It doesn't really make sense to me. But he's a professor. He does what he does. We're going to determine the gain k for which the system is marginally stable and the roots of characteristic equation for this value of k. Determine. Yep. Okay. So what we're gonna do is we're gonna select the highest value, which is 90 over 7. All right, and how should we do this? Okay, so we're gonna look at the first column again. We're looking at the first column here, right? If we put 90 over 7 into here, we put 90 over 7 into here, what would happen after that? You get 90 over 7 times 7, which is just 90. 90 minus 90 is 0. So we're not going to look at that. This would give you a value of 0 if you put 90 over 7, obviously, because we found the value 90 over 7 from that. On the other hand, though, if we put 90 over 7 into here, that'll give us 180 over 7, right? 90 over 7 times 2 is equal to 180 over 7. So that tells us that we're going to focus on the even polynomial exponents. So that's going to be this one. That's going to be this one. And it's going to be from the first column, okay? So let's rewrite that with the values of s, right? So it's going to be 9s squared, and it's going to be plus 180 over 7. If you remember, this last value is s0, which is also known as 1. So there's not going to be an s. So these first two, right? And this is going to be our... sorry, I forgot to write this at the beginning. Let me just... Control X, Control V. Put it over here. This is going to be our PA of S. PA of S. And as it says, we're trying to find marginally stable. So we're going to take the derivative over here. Oh, sorry. No. We're not going to take the derivative. We just have to find the roots. My bad. So this is going to be taking the roots. So this is going to say we're gonna paste this again, and we're just gonna set it equal to 0. And I'm starting to think now that I didn't have to write PA of S, but it's whatever. We're gonna set that equal to 0. Now we're gonna take out. So this is like a little bit complicated, right? What you can do is you can actually take out the 9. So if you take out the 9, this just becomes s squared, and this becomes 20. 20 times 9 is 9. 20 over 7. 20 times 9 is 180. Right? Okay, so for which the system... Determine the gain k for which the system is marginally stable and the roots of the characteristic equation for this value of k. Yep. Okay. After that, we just have to find the roots. We've determined that this is what makes the system marginally stable, and now we just have to take the roots. So let us take the roots. It is going to be... What is it going to be? Oh, it's going to be very simply s squared plus 20 over 7 is equal to 0. I don't have enough room. Okay, we're at the end of the page, so that's fine. It's going to be you subtract the value of 20 over 7. Sorry, I just had to think right there. It's one of those those moments where you just have a brain fart. But it's going to be negative 20 over 7. Then you take the square root on both sides. S is equal to plus or minus J square root 20 over 7. Okay. And with that, we've now found the roots of the characteristic equation for this value of k. With that, that's pretty much it. That's all we have to do for the quiz. This is pretty easy. Like if you really think about it, this quiz is pretty easy. There's a lot of math, yeah, but this quiz is fairly easy just because of how repetitive it is. We're basically doing the same thing 3 times, just 3 different ways. Where in other quizzes, we were doing a bunch of different things, which could very well confuse us. But this one is the same thing 3 different times and 3 different in like 3 minorly different ways. Because I'm saying that it's the same thing, but I'm saying it's also different. 3 minorly different ways. It's basically the same thing. But there's a lot of stuff where you could just simply get wrong, right? Oh, and in this problem, I forgot to mention. In this problem, oh, yeah. For this problem, what I got wrong was I literally just put k plus 10. That was the only difference I did, and it made me get the whole question wrong. So do not do that on the quiz. Take your time with it. Take it really slow. Take as much time as you need to solve a problem, as long as it's within the time limit, whatever, 40 minutes, whatever we have. And recheck your answers. Honestly, for this quiz, more than any other quiz, you're going to want to recheck your answers because I literally got every question wrong. So take your time, recheck your answers. And honestly, that's pretty much it. I hope you guys do well on this quiz. I will be posting this to YouTube, and I'm going to also, what is it? I'm going to post this to YouTube, and I'll also post these answers on the practice quiz number 3 forum. That's what I was looking for, forum. I'm going to post this little paint thing on practice quiz number 3 forum. And yeah, that's all. Hope you guys do well on the quiz. I hope you have a good night or a good day, whatever time it may be. And I will see you guys later. Have a good one.